Hi. Now in this tutorial what I want to do is show you how we can integrate cos ax plus b, sin ax plus b and sec squared ax plus b with respect to x, where a and b are constants. Things like cos 5x plus 2, sin 2x minus 3 and so on. And I want to show you the similarity that we have to integrals that we should already be familiar with. The integral of cos x with respect to x is sin x. Notice how the integral of cos ax plus b is the sine of ax plus b, only we've got 1 over a in front of it. The same with this. The sine of x is minus cos of the same angle x. So if we integrate the sine of ax plus b, we get minus cos of that angle ax plus b, but we have the 1 over a in front. And the same applies when we integrate sec squared x with respect to x, we get tan x, tan of the same angle here. So the integral of sec squared ax plus b becomes the tan of ax plus b, but it's again 1 over a in front here. Why is it 1 over a? Well, for the moment, let's just accept this rule. But at the very end of the tutorial, I'll show you why it's 1 over a. Now for the moment then, what we'll do is a few examples, and then I will give you a short exercise to do afterwards. So for the first example, let's just integrate 3/4 then of the sine of 5x minus 2 with respect to x. Now, when you get a constant in front of a trig function, or any function for that matter, you can pull it out in front of the integral. So we've got 3/4 times the integral of sine of 5x minus 2 with respect to x. Now, we can keep that 3/4 there, and we're integrating sine of 5x minus 2, sine of ax plus b. It's got that format, 5x minus 2. The a is the 5, the b is minus 2. We're adding minus 2. The result, though, is minus 1 over a cos of ax plus b. So the a value is the 5, so we've got minus 1/5 of the cosine of 5x minus 2. And don't forget that constant of integration plus c. We just need to tidy this up now, and we end up with minus 3/20 of the cosine of 5x minus 2 plus the constant of integration c. Okay, well, that's a fairly straightforward example. Same kind of thing would happen if you've got a cosine here or sec squared. Just make sure you pull out your constant and then use the relevant formula. Let's try this one though. It looks a little different, but fundamentally it still follows the same kind of theme. It's 4 sec squared 2 minus 3x all divided by 5. And we're integrating that with respect to x. So we can think of this as 4/5. 4/5 times the integral of sec squared of 2 minus 3x with respect to x. So it's going to be now 4/5 times this integral. And this integral, sec squared 2 minus 3x, has this particular style. So it's going to be 1 over a tan ax plus b. The a value though is going to be the minus 3 here, ax plus b. A is minus 3, the b is 2. So we're going to have 1 over that a value, 1 over minus 3 then, times tan of 2 minus 3x, and then plus the constant of integration c. So we just need to tidy this up, and we get minus 4/15. Minus 4/15 then of the tan of 2 minus 3x plus the constant of integration c. Now here's one that doesn't look like one of these at first until we modify it. It is the integral of 3 over the sec of 2x. Now we see this as 3 times the integral of 1 over sec 2x. And don't forget that dx on the end. And then what we can do here is remember that sec 2x is 1 over cos 2x. So we've got a stacked fraction here. And to clean this up, we just need to multiply top and bottom by cos 2x. And that will give us 3 times the integral of cos 2x with respect to x. Now this has the form, the cosine of ax plus b. The b value though in this example is 0. So using this result up here, we've got 3 times 1 over the a value, 1 over 2, 3 times a half, which is going to be 3 over 2. And then you've got the sine of ax plus b, just simply the 2x in this case. And then you've got your constant of integration plus c. So, I hope that's given you some idea. And what I've got next is a few examples for you to try. Okay, so I've got 3 for you to try now, and just pause the video and come back when ready. Okay, let's see how you got on then. Well, the first one, we've got 5 times the integral of cos 4x minus 7 with respect to x. Fairly straightforward. All you've got to do is have the 5, and then the integral of cos 4x minus 7, we need to divide by our a value, so it's going to be 5 over 4. 5 times a quarter, giving the 5 over 4 sine of 4x minus 7 plus the constant of integration. Now for this next one, what I'd want to do is see this as 2/7 times the integral of sine of 3 minus 8x. And then we've got to integrate that with respect to x. So the a value is the minus 8 this time. So we're going to have 2/7 multiplied by, and we're going to have 1 over the a value, 1 over minus 8, or minus 1/8. And then we've got the integral of the sine part, and that's going to be cosine of the 3 minus 8x plus the constant of integration. We just need to tidy this up now, and this is going to give us 2 over minus 56, which you could cancel down again. You'll notice that you could say 2 into 2 goes 1, 2 into the minus 8 goes minus 4. So you end up with minus 1/28 of the cosine of 3 minus 8x plus c. Now with this last one, we've got the integral of 3 over cos squared 2x minus 5. So how did you tackle this one? Well, I'd pull out the 3 first of all, and I've got 1 over cos squared of 2x minus 5. That's integrated with respect to x. So what is 1 over a cos squared function? 1 over cos squared of an angle is going to be sec squared of that angle. So I can think of this as being 3 times the integral of sec squared of 2x minus 5 with respect to x. And so the integral of sec squared ax plus b becomes 1 over a tan of ax plus b. So there's our a value, the 2, so we can say 3 times a half, which is 3 over 2, and then tan of the 2x minus 5 plus the constant of integration, plus c. Now I did say I'd show you how we derive the results for the integrals. And the best way I can think of doing this is just say taking y equals, say, the sine of 5x minus 2. Now if we were to differentiate this, what would we get? Well, we have got more than one term here. It's not just simply x, not sine x, it's a composite function, so we need to use the chain rule to differentiate it. If you're not familiar with the chain rule, just a brief reminder. It is that if you want to find dy by dx, you can say that this is dy by d something, dt say, as long as you multiply it by dt over dx. You must have the same value here. It's as if they cancel out and just return dy over dx. And in this example, what we'll do is we'll say where t is the 5x minus 2. And so that means that y is equal to sine t. So when it comes to finding dy by dx for the sine of 5x minus 2, we've got to do dy by dt first of all. Well, y equals sine t, and we should know that if y equals sine t, dy dt is going to be cosine t, cos t. So we could write cos of t here, but remember t is 5x minus 2. And then we need to multiply this by dt by dx, and dt by dx is going to be simply 5. So we could multiply this by 5, but really it's best if we put constants in front of trig functions. So we'd get 5 cos 5x minus 2. Now if I was to multiply this by a fifth, for instance, that fifth, being a constant, would get carried through into this part here, and so we'd have a fifth times the 5. Now a fifth of 5 just gives us the cosine of 5x minus 2. So what this leads to is that the integral of the cosine of 5x minus 2 with respect to x would be 1/5 sine of 5x minus 2, because if I differentiate 1/5 sine of 5x minus 2, I get the cosine of 5x minus 2. Don't forget that constant of integration. Now if you compare this idea to integrating the cosine of ax plus b with respect to x, you can see, I hope, that we always differentiate the sine of the angle. In this case the angle was ax plus b, and if we had differentiated that using the chain rule up here, we would have ended up with the a value in front of the sine, just like the 5 here came out the front. We don't want that a value, we don't want that 5, so we had to divide it out. We had to do 1/5, or in this case, if we want to divide out the a that would be in the front here, we'd need to do 1 over a times it. And we got our constant of integration. Now I could apply this idea whether it was sine ax plus b or even the sec squared of ax plus b. You'd always find that you've got to divide out that a that you create via the chain rule by timesing by 1 over a at the front. So I leave it up to you to try and experiment. Try and prove to yourself that the integral of sine of ax plus b with respect to x would be minus 1 over a cos ax plus b, and similarly the integral of sec squared ax plus b with respect to x would be 1 over a tan of ax plus b. Okay, well that brings us to the end now of this tutorial, and I hope you found it of some benefit.